I don't know what the heck this is on. Oh, okay. So let's look at, oops, that's not what I want to do. What is that? So we're going to look at the existing tools. So we have, I think I deleted this folder. Oh, this folder will not die. What the heck? Goodbye. I don't know what's wrong with my Windows, if it's got like a virus or something, but I can't delete that fucking folder. Fuck off. Whatever. Okay, samples are in here. And then this was provided, so I'm gonna look at each one of these, see what's going on with that. Bytes per vertex structures. Um, yeah, so yeah, yeah, okay. This seems kind of almost retarded. What the fuck? Yeah, so there's gonna probably be a dynamic vertex structure, I guess, in these type of games within the Xbox 360 era. I think DirectX 10 or DirectX 9 introduced the um, uh, what is it, flexible vertex format, which is like basically dynamic vertex structures for the DirectX library. I don't know, Microsoft introduced it in like one of the versions of it. Xbox 360 is where I encountered it. Basically, they uh, won't define data that you're not required to have on a chunk of geometry that you're not using. Like if you need vertex colors, it will use them. If you're not using them, then there's no point storing them. So that's the whole premise of the vertex flexible vertex format, which is basically just a dynamic vertex structure. Some games give a descriptor. The descriptor actually describes the format. I've seen some descriptors that are very elegant. Just using bit mask or something, 32-bit flag area to describe the entire structure. Pretty impressive stuff. In this case, somebody's mapped them out. They've noticed some particular sizes, and they've mapped them out, which is great. But I don't really understand why the 4-byte things. Yeah, okay, there's bytes that are being used. That's probably this is all this is telling us. This is really just really pointless. Because it's not describing what these other data structures are. We don't know. Are these float points? Are they not float points? Are they half floats? Are they integers? So this is not that useful. File sections are a little endian. Well, if it's a PC game, I would assume it'd be a little endian. The values should be read as blah blah blah. Parent name. So this is the structure, but I'll be honest, doesn't make any sense to me. Sections are a little endian. Like, why wouldn't they be? If the value is this number, it should be read as this number, this number. I think they're just trying to explain what little endian means. So that's okay. Parent name. Total number of indices. Indices are stored. The count is this in hex. Convert that to decimal. Then you multiply them by 2 bytes, and you get this, and that's this. it's like it was written by a 2-year-old. This is hilarious. I love this. Number of you in the unique spot wrong. What the fuck? Okay, well I do need this, but that's sad. That's really sad. And we have the unknown structure, so I also need that. So I'm gonna put that over there. Actually, this is probably useless to me, but actually all of it's useless to me. In fact, probably most of it's self-explanatory. But I'm gonna hold on to this. That seems to be the most complete. structure. For a while, I was struggling on, how to communicate structure to other people because it's such a dynamic problem. And I just came up with a solution that just using C structures are just the easiest to communicate things with. Um, so you have a struct, you give the name struct, and then you give it a name, and so you would, you call it the header or something, and then you would just would define what's inside of there. So it's pretty easy. So you can use whatever. You can use the actual types like char or short or whatever, or you can just go something like uint 8. I think underscore t is the actual type, but that's probably self-explanatory enough. And then you could just put in whatever, like the version, and then it's really easy. And then so if you have another substructure up here, I'm gonna call this the version. Um, I don't know, game type or something, right? And then you can actually pipe this into here. It's probably not right, but you can't have duplicating names like that. But then you just pipe it in there and just substitute it. And so that's really great when you have dynamic structures, and you can communicate it that way. So I like using the C structures to communicate format stuff. And then literally, if you're going to write a program in C or C++, you just copy paste. Not only that, you can also copy and paste them in Python or MacScript, and they're nearly translatable. The Python and MacScript don't have the type. They don't require the type at all. You just require the variable. But you could just shift that over to the right and make it a comment, which is fine. Yeah. Hex Editor. I was looking at this earlier, so we're gonna close it all because I moved. Oh, that's why I couldn't delete that folder. I was wondering why. Let's see if that works now. Nah, so I have something else open on it. Whatever. It's probably a text file or something stupid. Okay. Okay, I wasn't given a whole lot of samples, or was I given a lot of information, which I hate. I really like to have most of the information in front of me. Somebody had said there's a line that appears in the game when you export the model back. How the fuck am I supposed to know what that is? I have no fucking idea. I don't even have the fucking game installed. I have no fucking idea where this line is. Didn't send no screenshots, no other information, just says there's a line. What the fuck does that mean? A line? What the fuck? So I can't do nothing about that. I did download the game, which I shouldn't. It shouldn't be my responsibility to buy, purchase, or download or pirate a game to figure out what this fucking line is that you're having a problem with. Somebody should just do their due diligence and explain it better. You know what I mean? If they're having a problem, it doesn't make sense for me to inherit your problem. You should, spend the time to describe the problem properly. Then the other problem or issue was raised, I think. Whatever issue was raised. The unknown data structures. They just don't know what they are, I think is what I got out of that. So my goal, which for the next hour, because I have to go another hour, I got company coming, so I might have to cut this off early, but is just to document the format in C structures so that I can utilize it. There is a Mac script, but I assume it's not written to the way I like my code written. So if I bring it in here, we'll have a look. It's probably messy. So we know the first thing we have to read, which is the indency count. So we'll see it pretty obvious. So here we go. This is probably it. Yeah, it's like, yeah, this has got to be it. So they press the button. It checks for something, so it deletes the stuff in the scene. Opens the file, and then it starts reading, which I don't like doing it like that anymore. I used to do it like that, to be honest. I don't. It's just really hard to keep track of stuff. So I put everything into a struct now, a structure, so I can see it. But they have lots of comments in here. So obviously they read this value, they print it to the console, they for some reason create an array, they store the indices to an array, and it goes on and it continues. So it's not totally unreadable, so this will help for sure. But one of the things that I don't like, which I stopped doing, is scope. For some reason in MaxScript, um, probably in Python as well, I'm not too sure. But as soon as you declare a variable, it becomes a global variable, which is insane. Which means I can still access that variable from any other script, or just access it through the scene. As soon as you declare that variable, it now exists in the memory. So it results in massive memory leaks, to be honest. If you're having an array that's massive, it just stays in your memory. So it consumes a lot of memory and slows the system down. So I don't like doing this. So I like to destroy the objects or the variables that get created. So the best way to do that is to encapsulate it and then expressively denote that declaration as a local scope variable. So that way, once it leaves the scope, it destroys that variable, and garbage collection should remove that automatically. Otherwise, you can invoke the garbage collection to remove that shit. So in C++, you have to be responsible for all your garbage collection, but like MaxScript and Python, it's all automatic garbage collection. The problem being specifically in MaxScript, I don't know about Python, but it can the garbage collection can not work the way you want it to, and then you just have too much shit going on. So already, I don't like the way this is. The other thing is, let's say you have to switch the uh, the endian. That's kind of a problem too. But I think they didn't give me any 360 samples, so I'm not gonna worry about it. So okay, so we're just gonna do format analysis. I'm gonna try not to read those documents until I do my analysis, and then I compare them. But I probably won't get that far. Okay. So we need two files at least. We need a small file and a big file. So I don't know if I pulled this in now or earlier. I can't remember. I was talking too much. So we got this one. Okay. Two samples, varying sizes. The point being one fits on the page, one doesn't. Okay, so you come up with a guess to the structure, and then you verify it with a larger one. Well, you don't have to, but we can. It's good for verification purposes. Okay, and yeah, just bring up a notepad. Just go. Yeah, it's easy as that. Okay, so I already know what this does. This is the indices, so we can check that. So it's going to be index count. So we can do this in a structure style. So we can call this this is the juiced, is it juice or juiced? Juiced bin model. Okay. We have the index, what do we call it, face count. Okay, we have the indices, we call those faces. And for I equals 1 to face count, do faces, read short. Okay, so we got this thing, so I have this right now in decimal, switch it back in the hex, and we'll just jump through here. 7C, and 7C, so it is, in fact, as I said it was. I don't know if these are, if they have a type or not. Let's see here, so we have 0, 1, 2, 2, 3, 3, so that's incorrect, obviously, so that's probably a triangle strip. That's probably what that is. Kind of more about that later. Okay, so we just have to make sure we're in the right spot. So we're in here. Click, clang. Okay, now we're here. We have a 1. Don't know what that means. We have an integer. integer, so we'll call this unknown. Do it like this, and that's very long. Don't know what that is. Then we have a string. It's a string from here. It's probably a fixed size. Otherwise, there would have been some number preceding this. It's probably the model name. I would assume. You call it model name. What a material name. Yeah, I'll call it the model name. Mesh name. That's going to be a read string. I'll just put in brackets here, 32. And then that brings us about here, which I don't know what this does. So I'll just reinvoke this a couple times. And right here kind of matches this, which is curious. So at this point, I'm lost. So we're going to verify what we learned and compare it with this one. So this is, just copy that. We'll skip down here. Okay, so it's a different number. So we have 14, 20. Okay, that's interesting. Then we have this should be 32. So about there. And then of course we have these numbers again. This time not matching. So that's strange. So we have 3 integers, and then it continues with this thing. This looks like I don't know. Looks like this down here might be the vertices, but this looks like maybe a bound box position, something to that effect. And then some other crap that's down here. Could be a mesh table or something. So we really can't do anything until we break through this area, unfortunately. But yeah, so this is pretty much holding up. I can put some things in here. Always 0. Some count. I think this is 0 as well on both the samples. Always 0. Okay. And then we need to verify what this is really. So it looks like we do have a 1, a 2, a 3, and then a scalar value. So there's something going on here. I don't know what this is, but it has a fixed structure. So I'm gonna, this is kind of cheating, but we're just gonna copy this, and I'm gonna paste it here. And it goes blue when it doesn't overwrite. But the fun part about this is I can paste it a second time, and the things that don't go blue are things that didn't have to get changed. So I can use this to kind of see if there's a pattern to this madness. Perhaps not. Yeah, there might be some. Yeah, there's some fixed structure to it. Like, this looks like it's fixed up to this point. After that, it's not. So, because we don't know what it is, we just, for now, we just sub in what we can guess what it is. So obviously this is a float of some kind. I didn't name this right, but 2, 3, 4, 5. So it's just going to be read float. And we have 4 of these. Okay. That brings us here. Okay, we have 1, 2, 3, 4, 5, 6, 7. This is another one. So 8, 9. Let's check the other one. 1, 2, 3, 4, 5, 6, 7. Yeah, I would be in the 7 range. I think here is this a scale value maybe? No, position doesn't really look to have any specific correlation. We'll just say there's 7 of these in here. 1, 2, 3, 4, 5, 6, 7. Yeah. Don't know what that is. Then we're here. Let's see here. I gotta make sure I'm on the right spot here. So 1, 2, 3, 4, 5, 6, 7. Yeah, and then we have a blank, and then we have another one. A blank, and then another one. Okay, let's just do this then. 3, I think, is in here. So that should give me 1, 2, 3, 4, 5. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Alright, so what did I leave off from? I think I left off from here. Okay, the 12, I think I said. Yeah, 4-bit. Okay, so right after the 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No way. No. What did I do? I read 4 at the beginning, right? Oh yeah, no, 12. So, let's read from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's not really 12, is it? There's another float there. Yeah, another unknown. Read float. I'm gonna just have to just mess with them. I think probably just lumping it into one massive array is probably a better idea. I'll clean this up later. But we'll get back over here. So this is, I'm just gonna document it up to about here. Just write it in the way it is. So, yeah, read long. So 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so something weird's going on there. So just 4 of these. Okay, and then these are shorts. 1, 2, 3, 4, 5, 6, 7, 8. 8 of those. All right, 8 of those. Okay, that should put us about here. Okay, and I think this is getting really close to that vertex structure, so it looks like this is a double. I mean 32, it's double of its current size, which is 16. So I'm just going to expand it out. It should just line up eventually. There we go, it lined up now. What is this actually? 32, yep, that's right. So where am I right now? So usually what I do is I just look at the first vertex, which is probably this one, and then I just I mark it, and then I scroll all the way down until I can see where this ends. It looks like it potentially ends here, but it looks like it continues on. Continues on some more. That's insane. It continues on all the way down. It might actually continue like all the way down. This might be different vertex structures. It's really hard to say. Yeah, I'm not too sure. So in this case, we'll just grab a random number. Well, I don't have to like totally grab a random number, but we can do this. It's going to tell us the size, so 25 to 24. So 25, 24 divided by 32, that's about 78. In hex, that's about 4e, and then we have the 4e. So most likely this is the vertex count here, and then these 4 we don't know. They do whatever. So yeah. So these 4, let's drag them down here. This one we know is the vertex count for sure, and then the vertex data is dynamic. Okay, and then now we can kind of guess where this goes. So we'll just do the math here. So 4e times 32, that's the number. From here, we skip down. Yeah, I think I have to use the hex version of that. Skip down, and this stops about here. We have similar type of data structure here. Oh boy, that is a doozy there, isn't it? Um, honestly doesn't make any sense. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 floats at the ends. Very basic structure. But we have all these unknowns, so yeah, so let's say this is 11 and this is just read float. Okay. And then we will reduce this down. I think this is something absolutely, but the rest of it I don't really know. So 1, 2, 3, 4, 7, 8. So we'll just say this is 8, you know. Keep it simple. Okay, this I'm pretty sure is something. Alright, there it is. So, okay, I actually have some time. So let's look at the format that was provided and see how this actually fares. We matched up. Okay, I did a terrible job here. I don't know pretty much nothing. So let's see what this thing says. So it's okay. So the number of indices that would be the face count. Okay, indices are stored in twos or 2 bytes. That's right. So to skip that, it's just index times 2. Okay. Then we get the number unique meshes in the file. So the number of meshes is probably that number 1, which is interesting because the larger file, I didn't even check. There must be, yeah, there must be other submeshes. Interesting. Okay. So we'll mark it here. Number of meshes, in theory. Okay. So start of the mesh. So this is, okay, so we have this. So this is probably another struct. This is probably the mesh. So I'm gonna do that. 32 bytes. Start index. Okay, that's interesting. Number of indices. So we got here. So, yeah, starting index. Geotype. That's probably the type of faces, I'm assuming. Face type. We have the 44 bytes. Structure shadow data. Shadow data. 44 bytes. Visible distance. Okay, hold up. Hold the phone. 44 bytes. Okay. So it's 11 longs. 1, 2, 3, 4, 5, 6. Okay. So that's almost. Okay. And then it's saying that this one, which is one of the floats, which might as well just put inside of here. Jesus. So this has something to do with the other stuff. Visible distance, invisible distance, deformation, and other unknown data structures like shadow data. Okay, so this seems to be a fixed amount. And then it's getting into those other integers. Unknown data structures, 3, 4, 5, 6, 5, always have the same data per. Before, seeing 2 different structures. Okay, that's creepy. So there seems to be an additional structure somewhere. Varies in length. Yada yada yada. Yada yada yada. Yeah, so there's, yeah, I see. I think I noticed that on here. It looked like it had changed. Let's see, there must be some complex data there, which is probably dependent on the type. So that'll be fun to figure out. No, not really. Bytes per vertex, number of vertices. Okay, so there's actually just before the number of vertices, This is 32, so this is actually the stride. So down here, this is actually our vertex stride. Okay. And then this apparently is some other structure. But at some point, I think it's dynamic. Somewhere in, I think after here, it becomes dynamic. That's probably denoted by this stuff here, I'm assuming. Function, okay, provides functions, probably a sort of data map, different for each unknown data structure type. But consistency of data structures have been noted. Consistencies. Okay, so what I have to do is, okay, there's not much I can do there, so we're going to go and look at the script and see if it elaborates on that unknown data. Yeah, okay. So the geometry type we get, prints it, says, see if there is any other value other than 0 and 1. If so, inform. I'm assuming 0 and 1 denote if it's going to be triangle strips or triangle list. So let's try to see where that is brought up. Yeah, so that's where it's brought up. So this is, yeah, so it's a face type, which is understandable. So that we know, okay, and then we get into the unknown structures. So we just follow up here. So there was, okay, so we have face type, and then he's reading 11 floats. 1, 2, 3. Okay, I'm reading more, but that's because they kicked this out. So I guess I will kick this out of here. So it's 8, 7. So we have 7, and these are floats. They're calling this the okay, the distance when the mesh becomes visible. So when the mesh becomes invisible. That's so becomes visible, invisible. Okay, so we call that, well, I don't know. It's like the draw distance. And this is the invisible distance at which it becomes invisible. So we draw it between this distance, and then what? When it gets to a certain distance, we unspawn it. Unspawn distance. I don't know. And then it continues into mesh type. Okay, so we'll look at that. Unknown. Okay, unknown what this is. If I put an F at any place here, the model becomes invisible. Scene 0, 1, and 3. 3 enables dynamic real-time shadows. It sounds like shading. It sounds like the shader, more or less. On that, let's call it shader, I guess. Or shadow. Shadow, shader, whatever. Shader type. Render type, I don't know. Render type. Let's leave that over there, and then, so it's calling this the unknown structure. It says that that's the count. These values does not seem to change in the files I have seen. These values do change based on this variable. Should store from input per mesh for the export of the model. Okay, so they're saying that per this count, 1, 2, 3, 4 of these gets read. count, and then apparently there's a structure in here. I don't know. I can't really confirm that, but it's supposed to be like this, I think. And then yeah, so it kicks us back out of here, and we got the vertices and the stride, and then some stuff in here, and then we have the different counts. Equals this, that does this, equals that, does that, does this, does that, does this, and that, and that. Wow, that's a lot of, if mesh equals, wow, there's a lot of exceptions here. It's just really interesting. Driver, there's a variable called driver. So if the mesh is a driver mesh, the mesh name equals driver. That's really interesting. Doesn't make any sense either because it doesn't set the variable anywhere. I don't know where you're supposed to set that variable, but I haven't seen it get set yet. Just, what? Is that supposed to be string? The mesh would never be driver because this would never be initialized. Okay. And it's just normal import stuff. Okay. Oh yeah, what's up with this LOD stuff? Oh, okay. So the different meshes are probably level of detail. Yeah, I bet you. I bet you that's what it is. Got a few more minutes here. Yeah, so I guess, okay, so this just imports this stuff. There's actually no LODs in here, actually, in fact, so probably, I don't really know what this is, so probably doesn't really have anything to deal with that. Not really sure what some of these things are. Collision, mesh type, shadow cast. Interesting. Yeah, so I could probably just do this one, but I'm gonna do it up in a structure style. Because why not? Why not? So we're gonna create a structure. Actually, what am I doing? I have all this stuff here. I just copy it. Bloop. It's done. Alright, so I wanna have yeah, so we're gonna call this juice bin model. Bin file. Alright, yeah, it's a little more shorthand. Don't really know why I have it like this. I'll leave it like that for now. Okay, so in here we have the face count, number of faces, number of meshes. So this is, yeah, we'll call it mesh count. We have the mesh name, and then we have. Oh wait, this is its own structure, right? Yeah. Goof that up already. Struct jbin mesh. Okay, and then this is basically rolled down here now. This just comes up and into there. Oh yeah, this is different in here, so I changed out the double dash. This is the mesh count. I have to cut this off somewhere. I'll worry about that in a minute. So we have this on mesh structure. So this is the face starting index. That's really weird. Why that would be starting index? Unless that I didn't see any material list, but this is face start. Face count. This is a fixed length. all zeros from here on, except for that section. That's different. So we'll just mark it here. All right. So comma. This is the face type. Yep. We have more unknowns. So let's see here. I've basically just started here for now. And then I'm not sure what this is, but yeah. So there's 7 of those, so I have to put 4 in here. One, two, three, four, five, six, 7. Draw distance. I don't know what they mean, but I'll just question mark down. Render type, or called draw type, I guess. Don't know what that does. We don't certainly know what that does either. It's all unknowns, really. So 3, 4, 5, 6. This is apparently the unknown data structure, which I don't know what it does. So we'll just, for now, it seems like it might be collision data, based on the comments I read. So we'll just chuck that up to there right now. And we will just assign it this for now, and deal with that later. Okay. Vertex Stride. Okay. This needs to be, well, I was going to say it needs to be vetted. We'll have to check it, verify. Verify. Position. Oh, my computer's so laggy, but it's very laggy. Vertex Stride. Here. And we have this, and we have the vertex data. So I'll put this. I don't know why I did that. I just need to copy this. It's called vert. Text. Okay. No, the vertex data is the same, right? So we're gonna have position. The position is just gonna be something like that, right? We're gonna have normal for sure. Probably we'll have a text coordinate. We might have 2 texture coordinates. It's pretty typical. Weights. I don't know about weights, particularly right now. I'm sure it'll combine. What else can go in there? But anyway, so in here, there's, well, where am I actually? Right here. So this is just the vertices as an array, and we would just put that structure into there. Basically, we can't feed that in directly, so I might change it. I might change it. So instead, we'll just do that. And that way, I can just feed them directly. Yeah, that'll probably be easier for me to set up. So vertices is gonna have, this is gonna be more dynamic here. And then we have this whole area, which I got no idea what it does, which is unfortunate. But anyway, so we have, yeah, we'll just beat it up down here, so that'll be 8, and then bases in here. Oops. Okay, so this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's filled up. Vertex is dynamic. Yeah. Okay. So that's it. That's the structure. That thing. Okay. So this is Vertex data is dynamic. Okay. This we still don't really quite understand, but that's pretty much it. So there's our structure. This I gotta figure out. And then in here we have our meshes. Okay, meshes. And that's just gonna be up here. So we're gonna create a read function. So function read. Let's apply it with a file number. And we'll read from there. So in here we'll create another function called read. That'll be our file. So we input file. Put this down here. That will be our file. So just grab one of the larger samples. The largest one that I can find is this one. And we'll put it into here as a string. Okay, and okay. So that's gonna come into here. We're gonna call this read bin, maybe give some distinctness. So this is our read file. This is read bin. So in here, we're gonna create a local variable called bin, and we're gonna assign it this guy. Put this first, local f equals undefined. If f, well, not equal undefined. Actually, it would still be in the same line. I don't know, undefined. Then zip up on here. Else message box failed to open file. Okay. I'll just do a format print then. If try catch undefined f equals file or f open file read by its read binary. Yeah, so that's successful. Then we put that in there and we invoke fclose. So we can now close this up. Okay, so we can also no, it's pretty solid, I guess. Yeah, so yeah, it's good to me. All right, so we input the file. If the file is valid, then we should be able to open it. So the way we're doing that is basically just doing a try and catch. So if there's an error, then it's going to do a catch statement, and the catch statement is just going to return undefined. And then we'll just check to see if it's undefined. So if this is undefined is there, then we skip to this. We just say it doesn't open. Okay. Otherwise, f should be something. So f is assigned here. So f should be something. And we're checking that it's not this, right? So f should then be something. So then we create the structure here for this thing, and then basically we're just doing bin.read bin, and then we just apply f. It's pretty simple. Then it closes f. So it's a very simple script. Yeah, pretty simple. Say that. Damn. Okay. What am I doing right now? Okay. You have to go soon. All right. I'm gonna fill this out. So we're gonna fill this out here. Let's copy this here into here. Okay. So these are they're local inside of this thing. They don't leave outside of it. So basically we just make long F signed. And we have this. We need to declare I for I equals 1 to face count do. We have to do this as well. If face count greater than oops do. Alright, so we initialize, or what do I call that? We dimension it. So we're going to dimension the array, which is here, called faces. And then we go through and then we assign the face to each one of them. So that should be this, done. Okay. And then we're at here. This is the same thing. Put that there. So now it's the number of meshes. And it's basically the same thing. We just copy and paste this. Yeah, my grandmother's here. I gotta go. Shit. Alright, I just finished this line and I gotta go. Mesh count here greater than 0. I just cut through this. Jesus. Done. And then over here, this gets assigned here. Okay, and then probably I'm gonna have a function called readMesh, and then I input F into it, and it's going to read that. So this is actually going to need to be up here so I can dimension it. So I dimension it. I don't even know if it really does anything because we have to go through and we have to dimension them anyway as we go through them. But anyway, so or declare them as we dimension them, or declare them as we go through them. Yeah. So the dimensioning doesn't really quite work, really, as it does in C++ or something. But anyway, so that should dimension it. I hope. I really don't know. And anyway, so we assign it to that or part of the array, and then we should call that, and then I have to focus on that. But I gotta go. Anyway, so that was that. Once this is filled out, then we should have a complete struct, which I can then read and then dump. And then what I need to do is actually write a way of dumping this to a text file so I can compare readouts and check for differences so I can isolate and figure out what those unknowns are. So I'm also going to try and get the game installed and see if I can get more files to work with, because that's going to be important for later. Alright, gotta go.